Anyhow, the lecture today was going to be about collision, specifically different types of collision. So, while I'm setting up the creation kit here, let's go in-game just to see what we'll be working with today. Right, I pre-made these test meshes. So this is a simple static, which you can see at the moment doesn't have any collision. And also, I thought I put it down on the world, but let's see. I made a really badly textured sword. That actually does have collision, but not if you drop it. Let's just see that it just hangs here. And because it doesn't have any collision, I can't even pick it up, because the way that the game normally detects you getting a prompt is just looking at the collision of your cursor. So those are the two most prominent things that we'll be giving collision today. There you go. You have the objects here. Now, there are different types of collision, but the most important ones and the biggest differences are between static and clutter. So if you look at, for example, an axe, and you can see it has really simple collision compared with, that's a bad example. For example, this one's still quite simple but a bit more detailed. And the reason for that is that an axe has to move around, and those calculations are going to be, it's going to collide with stuff much more often, so those calculations has to be very fast. And the type of collision, well, in this case it's a convex vertices, but there's basically a bunch of different types. There is three basic ones. There's primitives, which is basic shapes like cuboids, spheres and capsules. There is convex vertices, of which this is an example. So that's a mesh that only has convex vertices, so only no inward turns. And then there is the mesh, which you'll other mesh types which you'll almost always see used by static, which is compressed mesh shapes, which can take basically any shape, including non-convex, concave shapes. But it is much more expensive for the game to calculate that, so it only gets really used for static. And the easiest to just show how to make it is the static collision. So I've already made the collision for this one. There we go. I forgot to move it up. So if I enable that, so this I should be able to just print it out. And move it there. So I can export this as let's say, into the same folder where I have the normal mesh. I just call this closet collision, and what it looks like, what basically the shader and stuff doesn't really matter. The important thing is the geometry. So yeah, if you open this in Nifskope, you can see it doesn't even have a material. But the important part is that it has the geometry that we want. So the standard method is just you select the NIF that you want the collision to go into, which in this case was that, the detail closet, the collision file, basically the file that contains the geometry, which we have here, closet collision. Make sure it uses the correct template, so which is basically the NIF that it takes the Bethesda, the BSX flags from, and we have examples of those on the wiki. So in this case, we just want to have a static. We want to use mesh data, so take the collision from the actual mesh, from the nitri shape in this file. If you select collision data, then it will check if there's a collision in that file and use that one instead, or collision fallback mesh, it will use the collision, or if that doesn't exist, use the mesh, but we just want to use the mesh shape. And for simplicity, just choose a single material and choose light wood, because these a closet would probably be made of wood that's pretty thin. So if we then open the mesh again, you can see the simple collision is now added to that file. And we should then be able to go in-game and show that it indeed has that collision. Blasted. I'll have to double check that then, that it is indeed using the correct mesh. This is what happens when I don't have time to test things beforehand. Because it's definitely added the collision. It does have the correct settings. But it doesn't have the BSX flags for some reason, even though it should have added that from the static. But I can pretty easily add that. I think it's probably BSX flags. Set that as the extra data. And there we are, BSX flags, and then simply go into an existing static mesh. So for example, the stairs, and copy that 130 for the static. And then one thing that's relatively important, sanitize, reorder blocks, because if your collision blocks are not in the correct order, so then you will get a crash in game. So if this this usually always descends 6, 5, 4, 3, 2, if that were to go up instead, you'd get a crash in game, which is something we see every so often in the Arcane University, students struggling with that. Hopefully I should now be unable to walk through. Ah, there we are. That's a lot better. If I had the height, I could probably... Ah, there we go. Jump on top. Probably not for... I can jump straight over. Also, shooting it with a bow. It's wood, so it, yeah, the arrow sticks. You'll see when you change the material, for example, stone or metal, some of these materials have it set so that arrows don't stick, so the arrow would bounce off. So that is a relatively simple way to get mesh collision, so, or well, for statics. One of the caveats I need to say with that, you can't just take the mesh and use that as the collision. Collisions, like I said before, are pretty expensive calculations. So that's why I also chose this very simplified mesh as the collision mesh, rather than putting in all the details of, say, these bridges and stuff. And you'll see that in vanilla Skyrim as well. If you have very complex meshes, they usually still have very simplified collision. But that's one of the more straightforward, even though the collision itself is relatively complex, it's pretty simple to make. Now, with clutter items, there are a few more things that you need to keep in mind. First of all, if you're going to make collision for clutter items and your 3D program doesn't export, say, convex collision or the other types of primitives very well, like the Blender Nif plugin, for example, at the moment, isn't great with collision, you can do a lot of it manually in Nifskope. But what you always want to do is just copy, so if I go to my sword, you'll see that most of it, that if you want to, first of all, copy the BSX flags, because we've run into that problem before. So simply copy the node, go to the, actually Control V to paste or not. Oh yeah. And it looks like it already added that in, which is very nice from Nifskope. It's into the correct place itself. This reorder box, because I'm pretty sure that the BSX flags have to come before the nitride shapes. So that's adding the BSX flags. Now to add the collision itself, again, you want to probably just copy this from a vanilla item that's similar in size. Now, I don't necessarily mean copying the collision. I will see that in a moment. It already added it correctly into the collision object, otherwise we would have had to enter that manually. Again, probably just best to reorder the blocks. Actually, let's first show you what happens if it doesn't, because, like I said, you want to see this decreasing. Instead, it's 8, 9, 10 instead of, for example, 10, 9, 8, which is what it should be. It added the collision, but what you'll probably see is when we go in game and spawn the item, that it will crash the game. It's not a very exciting demonstration, I know, but I think it bears repeating that you have to run spells, sanitize, reorder blocks when you're working with collision, just to make sure that it's decreasing. So the mesh isn't here. It's not using the collision point now. And there we go. We crashed Skyrim successfully. But yeah, spells, sanitize, reorder blocks, very important when you're working with collision. And then what Nifskope can do is if you click on a nitrile shape, in our instance the sword, what we can then do is Havoc create convex shape, which will generate a similar shape but for the mesh that you selected. So you can select the maximum round of error, which it gives you a pretty good tip of what that means. If you make this larger, it will make it less precise but better performing, whereas if you do the opposite, it'll probably stick closer to the mesh, but it'll be more expensive in game. And it looks like, yeah, it's automatically put it there, but then it reordered the blocks so that it is in the wrong location. So if we just reordered it so that it's in the correct location, you can see if we open the BHK rigid body, we can change, for example, the mass. So mass, of course, is not only, well, it is not how heavy it is, so how quickly it falls to the ground, but it's also how much it resists motion. Normally, the inertia tensor is a slightly more complex value. If you want to really know what it is, you should probably look up Wikipedia. But for an item like this, it's probably easiest to just leave the values as they are. You've got friction, so how much. So higher friction is probably how a higher friction means that it resists sliding motion more. Gravity factor is how much gravity affects it. So you can have something with mass that still resists a change in motion, but that doesn't have any gravity or very little, and more things like that. The radius is actually, if you look at this mesh, the radius is actually a part outside of it that it will also collide, so the sword will slightly be floating above the ground. Increasing the radius means that probably there's less chance of things clipping through each other. The calculations are going to be slightly faster, but you'll see, for example, the sword floating above the ground. And for very square meshes, a large radius means that it'll effectively become more and more like a sphere. So these kind of values are the things that you want to adjust when you're playing with your item, and really the only thing you can do is just adjust them, go in game, test them, preferably in a controlled environment, just so it's a lot easier and a lot quicker for you to test. But yeah, since we added the collision, let's go in game and prove that first of all it doesn't lead to a crash after doing the reorder blocks. There we are. And second of all, that hopefully we should be now able to select it, pick it up, and bump into it. that's also another thing in the creation kit. Things without collision, you usually can't easily select them except from the object window. It doesn't crash the game. It fell, and it fell through on top of the floor, not through it. We can bump it around. Probably should increase the friction given how easily it slides along the floor. Yeah, and even if we shoot it with a weapon, button. It just knocks into it. Now you might say, well, convex collision, that's not very accurate. I don't want the collision of my sword looking like a cut. I want it to actually look like a sword, you know, a crossguard and a blade and a handle. That can be done without resorting to a compressed mesh shape, which again allows you to do the concave collision. And one of the examples of that is the iron dagger. So if you look at this dagger is composed of 3 different primitives, 3 different just boxes.
Huh?
Hmm?
No. No, yeah, it is. What's it that?
His server muted. Go on.
Okay. Yeah, I mean, it's one collision object, but it's composed of these 3 boxes. So that means that with simple shapes you can make a somewhat complex final collision object. You'll see in Skyrim, for example, the buckets are not in compressed mesh shape, though they have concave areas. It's mod creation data. Fact. And just search for bucket. That'll be in. Yeah, it's all kinds of just. Let's see, 2, 3, 4, 5, 6, 7, 8, 9. Instead of resorting to the compressed mesh shape, which can just do the same shape as they've done, they've still made the effort of going through and making 11 different boxes just to avoid the compressed mesh. So that should give you some indication of how efficient these things are. They went through the effort of using that instead of the compressed mesh shape. And the basic principle is really simple, so let's remove that block. And insert BHK list shape. Doesn't want to do that. So now it's got the list shape. And we can introduce another block, so for example the Havoc BHK. We wanted to use primitives, so just 2 should be fine. Forget the BHK box shape, there it is. Subshapes, let's make that 2. 1 for the main thing and another for the crossguard. insert, yep, havoc, HK. Box shape. We haven't actually given them any dimensions, so that's a bit too wide. Let's look at the dagger to see what somewhat appropriate values are. So X is probably in the neighborhood of 0.3. 0.03. Yeah, that seems about right. Let's leave the Y at 1 for now, and then 0.3. That's a pretty accurate fit to what we had. Yeah, unused. Some of the unused values in collision, unfortunately, we need to still copy because they have an effect, or just sometimes the collision won't work without it. Radius was pretty important that we kept that. Something that is not 0. And the unused process just seems to just be a copy of the radius. And we could go through a similar sort of process to make so let's make the X direction 1, the Y direction 0.3. And right, make the X direction slightly smaller, so for example 0.3, 0.25 to make it mostly fit. Now you'll notice, aside from me forgetting to put in the radius field, and the unused integers, that this still doesn't line up. And for one thing, there is no way to adjust that here. So what we actually want to do is take a BHK convex transform shape, which is just basically a way to scale and rotate and translate these submeshes. So let's put those two in there. Convex transform shape, and insert another one. We're gonna need to don't worry about the indices, we'll just use this same spell we used the previous times in order to organize this. So the list shape, going to subshape, was it 0 for the transform, 1 for the other transform, put a 9 in this one, 8 in that one. You see, we'll need the same radius field as in the box shapes themselves. we need to copy the material. Forgot to do it here. Notice that you can select which material you want here. Just make sure that it matches everywhere in the NIF. Although, yeah, it has to match it pretty much everywhere in the NIF, I think. The same thing there, and here. Put that in there, and the unused values, which again, these may not necessarily matter, but if you're going to do it from the ground up, make sure to copy every little thing, just in case that it does matter and you might crash and that you don't have no, that you don't know why. If I were to actually make this for a real item in game, I'd probably just start with the this collision, just copy the whole thing over itself and adjust the values to match. But because I want to go through every little thing and explain what it does, we're going to go from the ground up here. Yep, that all seems to check out. And right, we wanted to edit the transform, so let's move this along that. Ooh, that's pretty high, but pretty far. Let's do 0.5. Seems almost correct. 0.5. 5.8. Yep, that seems to be in about the middle, and we can adjust the Y value to go slightly lower, almost. There we are. We don't see it, but it's probably... Well, let's make it slightly larger, just so you can see it. There we go. It's sticking out slightly. In the real case, you probably want your collision to be slightly inside the mesh. Not because we want the mesh to clip through the floor when it falls, but because of the radius field. So the radius adds a little bit of extra collision. So if you adjust for that so that it matches how far out, so if we make it so this piece is exactly that 0.005, which I should mention, that's havoc coordinates, which is approximately 79, sorry, just 70 times smaller than the coordinates you use in your nitride shape. The reason for that is very silly, but it's that in nitride shapes, 64, I believe it's 64, 64 units makes 3 feet, so a yard, whereas havoc coordinates, they use proper meters. So that's the reason for that discrepancy. You got 64 and a bit, which brings it to something like 69.99125 difference in scale. That's just something to keep in mind. Although it doesn't really affect things if you're using chunk merge, because chunk merge automatically does that conversion for you. So just make sure that it lines up in your 3D program. But yeah, something to keep in mind if you're adjusting the fields here. I could have looked into my nitride shape, see how far the X and Y values went, then divided that by the 69.99125 to get to how big it would have needed to be in havoc coordinates. Anyway, let's put this forwards as well. So three, no. That's one thing I dislike about Nifskope, the way it handles your input fields. That look like 1, 1, 8. Seems about correct, especially if we count for the fact that the radius is also there. Right, 10, 6, 7, 8. It goes up. That's probably not good. So reorder the blocks. You can see it goes BS info marker, nice string accelerator, the BSX flags, and the collision object, which is 10, 9, 8, and then 5, 4. I don't think the order of these things matters. As you can see, it actually goes up in the per convex transform shape within the BHK lift shape, but none of them are higher than the 10, and when you go from a convex transform shape to a box shape, it goes down. Anyway, let's save that, go into the game, and hopefully, if I've copied everything correctly, and I didn't forget to copy anything, the collision should be correct. It's always a big caveat because there are many fields that you can forget to copy, which is probably why it's just best copy something from vanilla and remove or adjust things as needed. It didn't crash the game so far. It looks like it landed properly, which is a big plus. And hopefully we should be able to see the intersection. Yeah, like there's actually some room here for yeah, in between the cross guards, rather than before where it was just a straight line. So those are pretty much the different types of collision. You can have convex collision, you can have, as I showed at the very beginning, static collision with a compressed mesh shape, which you can generate using chunk merge, or I think nowadays CKCMD can also generate that for you. And you can have a list of primitives. Now, it doesn't need to be just boxes. You can have, I think, out of all of them, you can have spheres, and capsules are also something that you can add. Yeah, so the box shape, capsule shape is one that you can have. BHK sphere shape is the other one, which is, you know, if you have something roughly ball shaped, you probably want to use that. But that's the basics of collision. I can't think of anything in particular that I had listed, but if anyone has any questions, I'll be more than happy to answer them.
I have a quick question from somebody who knows very little about this in general. Are you able, is there a threshold or a point in your mind where you're like, okay, this little item does not need collision whatsoever? Or for example, I noticed in Kettle Witch's mast of a ship, the ropes to the mast didn't have collision at all. That seems like an obvious one, but I wonder if you have more complex, I guess, places where you draw the line.
Not me personally, because I know the technical side of things, but in terms of just doing it, I haven't made that many assets. I can tell you it's very much like in 3D, like the polygon count, like the trigount. You know, there is always a trade-off between how realistic you want it versus how badly you're going to hurt the game. And obviously in things that don't occur very often and that are pretty special, you want to give them pretty good collision versus something that occurs very often and that's going to have a very high impact on the game if that's implemented. You want to use slightly more simple collision. But yeah, there's no hard line. Obviously, if you can look at similar items in vanilla, that always helps to give you sort of an idea of how much it should be, how complicated you should make it. But it's also personal preference, like how detailed do I really want to make it? If there's a hole in this chair, do I really want to make that hole, or so that people can shoot through it, or is that not really that important? But yeah, that's not there's not a hard technical line on that. It's always
I think your analogy was really good.
Yeah, it's always a trade-off between complexity of collision and performance hits.
Comparison to 3D made it click for me.
Good. Anyone else? If not, I'm just going to waffle on about collision layers, for example. All right then, collision layers it is. So, collision layers basically determine what everything collides with. So if you look in the creation kit, there is a, I forget where it is exactly, there it is, collision layer. Basically says which things collide with which things. So for example, Clutter, which is the one we're talking about now, collides with Clutter. It does not collide with, for example, portals, or stair helpers, or wards, or navcut collisions. It collides with most other collision layers. That's how you know which things you want to, and which collision layer you want to pick, and how you know what it's going to collide with. And you can change those things. I believe one of the, I'm not entirely certain about this, but I thought one of the more popular like dead body collision mods just changed one simple thing in collision layers that made it so you could stand on top of dead bodies instead of just push them around. But because dead bodies are pretty complex, that also was a pretty big performance hit, especially if you had a load of them lying on top of each other. And you know, there are some other things like making a trigger volume, make sure that things that enter that collision layer give you an event. I think there's a trap collision layer that specifically sends trap events. Yeah, probably that one. So if you want to make trap objects which are have a somewhat special collision, then that when something collides with them, they send a script event which can trigger all sorts of things. So that's how for example, the oil lamp trap works. Which, you know, if you shoot that one with a bow and arrow, it falls to the ground, lights a thing, and that basically works off of that. Just it detects if it's hit. If it's hit, play that animation of the oil lamp falling, and eventually it's like, you know, igniting. Well, I think it probably uses an explosion to place the flames and light the oil. And then in terms of what the material does, most materials that you can select especially the ones that you can select here, are linked to a material type. Just there we are. So material type. The material type, for example, coin, doesn't have arrows sticking. It determines whether arrows stick in it, whether it's a stair material, so if you can walk up it easily, and the Havoc impact dataset. So the impact datasets basically determine, among other things, but for material types they just determine, what sound gets played when I interact with this material and what sound interacts when I determine with the other material. And then some things have nothing defined, which means there's no response, but it can also mean if there's no response and there is a it was in special effects material type. So parent materials. So it means that you don't have to define everything about that material. If there's nothing defined, it will look at this and look if that has any entry within the impact dataset, I think, and then play the one associated with that. And yeah, also determines buoyancy, so how it reacts in water, which is pretty cool. So you can make something float or not float, or be more or less heavier. So I think cloth doesn't float, neither does glass, although interestingly it has a buoyancy of 0, so it's probably neutral. But then material wood, wood has a positive buoyancy, so it floats up in water, and arrows stick in wood. Oh yeah, skeletons are complicated even for me. But I hope it helped some of you who do 3D and who want to know what type of collision to choose. Or just want to know what settings to adjust to get the desired effect.
Does anybody have any final questions for Candoran before we finish off?
Well, glad to help. And if not, it's time to grab something to drink in time for the next presentation.